Hello everybody, welcome to the first Tech Weeklies of 2021. And today we have Ka presenting about Alexa, about HSL schedules for Alexa or with Alexa or something like that.
Yeah.
So Ka, if you're ready, take it away.
Yeah, thanks Olavi. My name is Ka, and today I would like to spend some time to show you what I've done with Alexa. Oh, and whenever I say Alexa, this device light up. So I was curious about Alexa, so I tried to make an application just to learn about how to make application for voice assistant. And in the meantime, I tried to make this app to look up HSL schedule for me. The agenda today, we're going to go over 5 topics about Alexa, the components of Alexa, the HSL app that I made, and the struggle that I had when making this application, and a preview about other voice assistant platforms. We usually see this device, which is not Alexa, by the way. So Amazon provide an online service called Alexa that is used to process your voice command and turn that voice command into something that you can send a command to be further processed by an Amazon Lambda function. And to facilitate this voice command service, Amazon also provide these devices called Amazon Echo. And you are not limited to only using Amazon Echo with Amazon Alexa, because Amazon also encourages people to use the free SDK to make custom devices that interface with Amazon Alexa. So you can actually build your own Alexa device. The anatomy of an Alexa app, it usually involves an Echo device that is used to capture your voice. Usually it's an Echo device, but it can also be your cell phone. When you download the Alexa application on your iPhone or your Android phone, then you can also use your phone as an Alexa device. So the Echo will capture your voice and send the voice signal to Alexa, and Alexa will process your voice to identify what you like to do, or in other words, try to identify the intent of your command. And Alexa will, based on the intent, will figure out what application or specifically what Lambda function to send the command over for further processing. When Amazon Alexa finish processing your speech, the signal will be sent over to the Lambda function, which we will go into detail later. And the Lambda function will produce a response that will be sent back to Alexa, and Alexa will deliver the response to your Echo device. Next, we are going to take a look at my SSL application. I made an application that helped me look up upcoming bus nearby my apartment. For example, when I'm about to leave, but I don't want to wait in the winter outside for too long, I can use this application to check how much time the upcoming bus will come, and I can give you a demo. So I'm gonna stop the slide. So this is the Echo device, and I'm gonna issue a command. Hey Alexa, launch Helsinki region tracker.
Which tram or bus do you want to track?
Tram 3 to Meilahti.
Tram 3 to Meilahti will arrive in 10 minutes.
Okay, so that's the demo that I know that my tram in that direction will come in 10 minutes, and I can estimate how much time I have before I have to leave my apartment. Let me resume presenting. Do you see my Alexa developer console?
Yes.
Okay, good. So in here, this is where you will develop the Alexa skill application. Like I mentioned before, an Alexa application will involve the Alexa skill part and the Amazon Lambda part. This is the Alexa skill part, where you will define, first of all, the invocation. So in here, invocation name, Helsinki region tracker. This doesn't have to be unique, but it's the keyword that Alexa will look for to identify your application. And previously you heard me saying launch Helsinki region tracker. So Alexa will know to open this application. And then moving on to the interaction model, based on what you say, Alexa will try to identify the intention of what I want to do. In a typical Alexa skill, we have a few default intent like fallback intent, navigate home, stop, help, cancel. These will be there when you first create an app. And this is what I created for this specific application. So there's only one main intent in here: track route, bus and tram route. In here, in an intent, we are going to define utterances. So in here, I'm looking for this specific track route intent. Whenever Alexa is hears something like for bus number, for tram number, and for tram number to some direction, or bus to direction. So whenever Alexa hear any of these utterances, it will know that I want to track the I want to perform this intent. And in here we have what is called a slot. When you define an intent, you can do something like for example, and then you open a curly braces, and then you can say car, for example, which I'm going to define a new slot, but I'm not going to do it now. And these slot will have a data type. For example, for the route number, I define it to be number because mostly the bus and trams are number. Sometimes it has name like tram 6H or 6T, but I only support number for now. So that defining the type is helpful because it helps Alexa to expect a number to capture the voice command better. The tricky part is this direction. This is a custom type. I created a custom type region. Let's see this region slot type. Okay, Helsinki region. If I make this application, for example, for New York subway system, then Alexa will provide me with a type including all of the name of location for New York subway system. But we don't have anything similar for the Helsinki region. So I have to define these custom name. And in here, I only have a few names around my area. But to make this application fully functional for the entire Helsinki, we will need to define every possible destination in Helsinki in the HSL system. So there's still work to be done, and this is not in no way complete. Back to the intent. Now that we know that we can define the utterances, and the utterances will try to fulfill the slots. So in here, I have two slots, route and direction. When these two slots are filled, meaning that they have a concrete value, Alexa will send these slot values over to the Lambda function for further processing. So when we have a value for route and we have a value for direction, we are going next to the Lambda function in the code section. In here, Alexa will provide you with some template, and this is the custom code that I have. And in this part, in here, we are just checking that this is actually the track route intent. And in here, the basic is I extract the slot value for route and direction into these two variables. And then I also look up my personal address, which I set in my Alexa application. And based on this, I can ping the HSL API to get the available HSL routes nearby my apartment. And these details are just for filtering, like we don't want a bus that is too near in the future that I cannot walk there in time, for example. So this is just some simple filtering. The main part is that we can extract the slot value and then perform action with what we want. And this is just a simple Node.js application. We have a package.json file where you can define your dependencies, and you can add more file, like I move my logic for getting a full address and getting routes to a different file, so I don't have to shove everything into this one big index file. When we finish processing, we will return the response back to Alexa. First, we will construct what we want to say. For example, if we cannot find anything, we say, sorry, there's no bus or tram today. Or we can say the main response will be bus or tram number to your desired destination will arrive in how many hours and how many minutes. When we have that sentence ready, we can invoke response builder, which is where is it? Which is part of the handler input from the Alexa SDK. The response builder will have a method speak, and then you pass in the string that you want to speak, and then you call get response, and this will be returned back to Alexa, and Alexa will send the audio, will produce the audio response to send back to your Echo device. That's about it for my application. However, as you can see that this is an online editor and it's not really ideal for big application. So here, I actually find the developing experience to be really awkward. For example, there's no log, there's only voice response, so it's not really easy to spot the error. I had this error when I copy and paste the URL for the HSL service, and for some reason I accidentally make this mistake to remove the key for the query string, but I didn't notice where this happened. And all that Alexa was doing was saying that there's something wrong in the response without me knowing where to fix the error. So it took a really long time to figure out what went wrong. So I eventually moved the logic for looking up the SSL stuff to a different service and have the Amazon Lambda to use a service instead, so that I make my Lambda function really simple. But in a production context, we can, instead of having to use this online editor, we can edit the endpoint. And in here, you can either switch to using some private backend using the HTTPS option here, or you can specify your own Lambda function that you develop, and you can test locally to have a rapid development. Yeah, so that's the walkthrough of the HSL application. Finally, I also want to mention other voice assistants available out there. The most famous one is Siri, and we have also Google Assistant, and in the top right corner, that's Xiaomi AI, and at the bottom we have Huawei AI and Bixby from Samsung. Out of all of these, of course, Amazon, Siri, and Google are the most mature, but the other platforms also have a lot of market in the consumer and appliance devices. So they can always use their voice assistant in their other devices, in their other electronic equipments and appliance. But for now, I can only compare the three most popular platforms, Siri, Google Assistant, and Alexa. Alexa is quite similar to Google Assistant in the way that you develop a skill separately. So on Google Assistant, you also have the same developer console interface where you design your skill, and then the skill will try to fulfill the slots, identify the intent and fulfill the slot, and invoke the serverless function, the appropriate serverless function. It's a little bit different in the Siri case, and I think Apple is trying to advertise that they are more secure because they try not to process your audio online as much as possible. They're trying to do everything on the device. So when you develop a Siri skill, it is usually a part or an extension of an iOS or iPadOS application rather than a separate skill, as in the case of Alexa and Google Assistant. So that's my summary of the different voice assistant platform, and that would conclude my presentation.
Thank you. I think we have time for questions if you like to answer some questions.
Yeah, I would. Now I can take question.
at least I have one question, because those Helsinki locations weren't there automatically. You had to like add them manually. But did you have to somehow record something also, or how did it automatically recognize your pronunciation of the names?
That is also a tricky part. I didn't have to record anything. So far, because these names are pretty also very easy to pronounce, so I can just say something like Merikatu and it would work out just fine. Or Meilahti would work out just fine in the demo. But for some other more challenging to pronounce languages, I think that we have to do some more work.
Nice. You just said Finnish is not a difficult language to pronounce.
Not at all, I have to say.
I have a quick question. How well does it support kind of multi-stage, or I mean stateful kind of conversation where you first have some kind of communication and then it remembers what did you say and then asks more questions than you answer them, and kind of being stateful?
Yeah, it does have stateful conversation interaction. I have not tried it. I only read about it, but it's pretty analogous to a cookie scheme where you have some kind of cookie similar to cookie object that you store the slot value that you can use for later intent, for other intents. So code-wise, this is where you extract your intent in the handler input, and I think the handler input here will also provide some method for storing and retrieving data similar to a key value data storage. Does that answer your question?
Yeah, thanks.
Yes, I have one question.
Yeah.
How do you test your code? I saw that there was a test tab in there.
Yeah. So right, I should have gone through this test tab. This is not about testing the code in here, because this console doesn't really focus on the Lambda part, which is why developing Lambda function here is not really ideal. If you develop your backend code separately in a Lambda function or in a backend, then we can test it in the traditional way. This testing here is more about testing your skill, including the invocation. So in here, you can speak or you can type a command and see how the response is happening. For example, can you say what time is it? So here it's gonna give you a response that to see if the conversation model is working as you are expecting. And in here, if I say launch Helsinki region tracker, and in here you see that it asks you the question that you are expecting, so you know that the conversation model is working. Oh, and before any more question, there's one thing that I forgot to mention at the beginning. Developing a voice assistant application is it can be very different from a traditional application because of the voice part. For example, in the invocation, originally I did not have the Helsinki region tracker. I was having I had something like a HSL timer, and this is totally valid, but I find it to be really awkward and difficult to pronounce HSL timer, especially when I talk to a voice assistant, because I have to be really clear and stretch my vocal to say HSL timer. And Alexa may miss that a lot of time. So designing an invocation name that doesn't take a lot of effort to pronounce is also the key factor in designing a successful voice assistant application.
Hi, I also have one question.
Yes.
So if you didn't have the Echo device, how difficult would it be to test the APIs and the Alexa functionality that you built?
Yeah. So you don't need the actual Echo device, because you can also use your phone as an Echo device. And like do you see my camera?
Yes.
So this is the iPhone, and in here I also have the Amazon Alexa application. Here is say tap to say Alexa, and I can and I can use this device as a Alexa device as well. For example, if I tap here and say launch Helsinki region tracker.
I found a few skills that might help.
Okay.
Do you mean Helsinki city bikes?
No, sorry. Launch Helsinki region tracker.
Which tram or bus do you want to track?
So it's performing in a very similar way as an Echo device, and you can start already testing your skill on device using your phone.
All right, nice.
That's actually pretty cool because then you can play around with it even if you don't, or like if you would like think about buying one but you're not sure if you want to have one, you could try to create some useful tools in it and then buy it later.
Yeah, totally, because you don't miss anything from using your phone. The phone application will behave in exactly the same fashion as the Echo device. The only difference is with the Echo device, you can have it around your house and you can have it to be always on, whereas in your phone, you will have to open the app. But that's good for development and testing.
Thank you, Ka, for an amazing presentation.
Thank you, and thanks everyone for attending.